Hi, linear algebra students. We will close this section of inverse of a matrix with a typical problem on a matrix equation. So, as we have seen in class, when we know that a matrix is invertible, it helps us tremendously to actually solve an equation for a matrix. Because instead of doing a row reduction process, we can simply multiply both sides by the inverse of an invertible matrix. All right. Again, this exercise has been given in the final exam, fall 2017, and it is in your reach, okay? It's actually not a hard problem as long as you understand the properties of inverses. So please try it on your own. We have done an example like this in class. So the reason why I put this on YouTube is really for you to check what you have tried. So try it on your own, and if you're completely stuck, then okay, listen to the steps. Otherwise, if you think you got the correct answer, and actually I wrote the answer in the lecture notes, so you should know if you have it correct or not, then you can actually watch this video and see the steps. Like if you got the wrong answer, where did you fall short? That's what's important for you to see. Okay, and we treat this pretty much exactly as a high school algebra equation, but we need to be very careful because matrix multiplication, as we discussed in class, is not commutative, and that will change a little bit of the steps. Okay, so what I mean by we treat it as a high school algebra equation is just that we will write it down here, okay? And we will work on it vertically, right? We will just, each steps, we will write them like this. So, okay, here, this thing is a little bit tricky, okay? And the main reason is because of the tree. So, what I'm gonna do here is I'm gonna put in front of the tree, I'm gonna put a matrix, an identity matrix, matrix I. And this is the equivalent of multiplying by 1, right? So you are certainly allowed to do that. The reason I do this is because I want this whole thing to be interpreted as a matrix, right? This is a matrix. And you could write it like this. It's going to be like tree. It's a diagonal matrix with trees in its diagonal and 0 elsewhere, if you remember. Well, this is the identity matrix, but like it has been multiplied by 3. Okay, never mind that. But that's why I multiply by I. Is just not to leave a floating 3 in my equation. 3, a floating 3. There you go. And then what I'm going to do is I'm going to use the property of inverse to say that the inverse of a product is the product of the inverses, but in the reverse order. Okay, that's one of the tricky parts. So we have here B inverse, X inverse, and 3I inverse. Okay, that's plus A is equal to the inverse of X. So this step, remember, what we're doing is we're using that AB inverse is equal to B inverse A inverse, okay? In general, this is the rule. Whenever you take the inverse of a product, it's the product of the inverse in the reverse order. And notice that it's actually nice because here I have 3 matrices, but it works with 3 matrices as well as it works with 2 matrices. You just reverse their order, that's it. All right, the next step, we're going to deal with the 3I inverse, okay? The inverse of 3I is actually just 1/3 I. And it's easy to see because as you matrix multiply, what will happen is that you will multiply every row by exactly by the 1/3, right? So So let's put it this way. 3i inverse is going to be equal to 1/3 I, which is going to be like this, like 1/3, 1/3, and all the way down to 1/3. Okay. If you're not convinced of that, I would suggest to actually multiply these two matrices, and you will see that you get the identity. The idea is quite simple. It's really first row, first column, so you'll get 1. Then second row, second column, you'll get 1. But everywhere else, you're going to get zeros because you will just have products of the type 0 times a number. So, okay, so that's what we're going to use here. And we're going to write this, B inverse, X inverse. And here what we have is 1/3 of I. Okay, plus A is equal to X inverse. So that's what we use. All right. Now, the principle is the same as high school linear equations. We will collect all the x's on the same side. So what we do is we subtract x minus 1 on both sides, and we subtract a on both sides as well. One thing that I should mention at this point is that as I multiply I by these matrices, it will just give these matrices. So the next step will be just to write 1/3 of B inverse, X inverse. And then I don't need to write the I anymore. And remember that the 3, we can move it around. Matrix multiplication with the scalar, like this commute, certainly. And then I'm going to subtract X inverse on both sides. So I'm going to get this. And then I'm moving the A on the other side. So I'll get the negative of A. Okay, so yeah, I'm going to complete this problem by putting a vertical line, and I will finish the steps over here. Now, the next step is to factor x, the inverse of x, but there's the tricky part. The problem here is that, or wait a minute, could I actually multiply by x? Would that be a more appropriate step? I think that's what I'm going to... Okay, yeah, I know what I'm going to do. So I'm going to begin by factoring this on the right, okay? So factor x negative 1 on the right. So what I'm going to have is, in brackets, 1/3 b minus 1 minus the identity times x inverse is equal to negative a. All right, and on the right means that it's really here that I have to put the inverse of x, not in front of the bracket. This is, again, because matrix multiplication is not commutative. If x is on the right here, it has to get distributed on the right. All right, so now that we are here, one thing that I could do is I could multiply by the inverse of this and then invert it. Okay, here, what would be the most appropriate step? I think it's easier if I just write multiply by x. Okay, let's do this. Write multiply by x. So what are we going to get from here? So here we have x inverse, which means nothing will be left here. We will have 1/3 b inverse minus I, but however, we will have negative a multiplied by x on the right. This is important. Okay. Then I will left multiply by negative A inverse. So the negative, what it will do pretty much is it will just flip the signs. So no problem here. We will just have like negative 1/3 B inverse and then positive I. Okay? And we will have, because it's left multiplying, we will have A inverse. So this is it. This is our answer. We solved this matrix equation for x. I'm just going to read if this is actually the answer I put on the paper. And yes, it is. Well, of course, on the paper, I is first. It's just to save some notation, but that is not a problem. I hope this helped. See you in the next video. Now, next topic. This closes inverse of a matrix.